Hi guys, welcome back. So in this video, we are solving a problem from Irodov based on center of mass frame. So the problem says we have two bars connected by a weightless spring of stiffness K and length in the non-deformed state L0 rest on a horizontal plane. A constant horizontal force F starts acting on one of the bars as shown. Find the maximum and minimum distances between the bars during subsequent motion of the system. If the masses of the bars are equal equal to m1 and m2, and the force F is applied to the bar m2. All right, guys. So this is the figure they have given. So we solve this problem by using center of mass frame. So it is simpler way to solve this problem. So there is another method of integrating the force. So that is a lengthier method. So this is a simpler method. All right. And then first the given diagram is this one. So they have applied a constant force F on bar M2. So we have to find the maximum elongation of the spring. So yeah, we as we know center of acceleration of center of mass is total force by summation of total mass. So acceleration of center of mass is external force F by total mass m1 plus m2. So equation 1. All right. So in the center of mass frame, if we look from center of mass, we have to give pseudo force on the two blocks here. So m2 into acceleration of center of mass and m1 into acceleration of center of mass. Basically, we give opposite to the applied force. So yeah, wait. So the masses are moving right side initially, right? And if you give pseudo force opposite to it, so it is seen it if we see in the center of mass frame. All right. So m2 into acceleration of center of mass and m1 into acceleration of center of mass. So this is the applied force. So if we do net force on this, F minus m2 into ACM. So this block moves right side by x2 and this block moves left side by x1. So these are the displacements of the bars. All right. And then if we substitute acceleration of center of mass from this in this, so we get m1 into F by m1 plus m2 on m2 F minus m2 into ACM. So if we solve this, we get m1 into F by m1 plus m2. So basically, we get equal forces on both the bars. So yeah, now we use work energy theorem here. So work done by external forces equals change in kinetic energy plus change in potential energy of the spring. So yeah, the basically work done by the two forces are, so force into displacement plus another force into displacement equals, so the change in kinetic energy is 0, and the spring potential energy half k into x1 plus x2 whole square. And by this, so if we do common m1 F by m1 plus m2, so x1 plus x2 and x1 plus x2 cancel here. So by this we get total extension in the spring is x1 plus x2 equals 2m1 F by k times m1 plus m2. So if we substitute same masses here, so we get the answer of A part, and B part already we have solved here. So this is, so thanks for watching guys. So if you have any doubts, comment below. Yeah.